Dear Professor, today me and my partners we will talk about our project, which is smart blind gloves. Our purpose from this project is the usage of the latest technology in order to help blind people become more independent in their lives. So we decide to design smart gloves. The gloves will be able to detect and sense the colors, vibrate, and speak the color out based on colors that glove touch. And it can know the distance between it and the object. For this project, we need to apply a circuit using Arduinos and build the systems with waterfall model, and we will pass through how does it work, the features and the advantages, and the component.
The color detector sensor has an array of 8 by 8 photodiodes, which is in total 64. These 64 are divided into 4 categories that have 16 photodiodes in each group. The first group has red filter, second group has green filter, third group has blue filter, and finally the fourth are clear without a filter. The sensor has 4 control pins, S0 and S1, which they are used for frequency scaling, while S2 and S3 are used for controlling the subcategories of photodiodes. The control pins are following digital logic to work. Also, the sensor has a current to frequency converter, which converts the reading of photodiodes into square waves that are directly proportional with the light intensity. And finally, the Arduino reads these waves and converts it into color results. Moving to the hardware part, for the sensor we will connect pin S0 to pin 4, S1 to pin 5, S2 to pin 6, S3 to pin 7, out to pin 8. For the SD card module, we will connect MISO to pin 50, MOSI to pin 51, SCI to pin 52, and finally SC2 pin 53. And of course, all the VCCs of the components are connected to the Arduino's VCC and all grounds to grounds. For the speaker, we will use the AUX wire. It will be connected to the ground and pin 46. And of course, the vibration motor, we will need to connect it to pin 2 and the ground.
For the sound feature of this project, there are 2 ways to interface with micro SD card devices with. The first mode called SPI mode, where it is much easier to code and use, and it will be used for this project, and the other one called SDIO mode, which is much faster and used much more nowadays, especially with electronics like our smartphones and digital cameras, but it is much more complex, so that's why we wouldn't use it for this project. And for the sound itself, it should have certain settings, like it should be in WAV4, and the resolution should be 8-bit, so the sampling rate should be 16,000 Hz, and the channel should be in mono mode. Lastly, for the code of the sound feature, this is the code of it, but it can be fixed and changed based on the project itself. But for our project, it should be like that.
Use a very standard ultrasonic sensor known as the HCSR04 and has the ability to measure distance between the range 2 cm and 4 cm and has a range accuracy measuring up to 3 mm. And the ultrasonic sensor basically emits an ultrasound of 40 kilohertz, which flows around in the air up to the distance of the ultrasonic range, and then it bounces back to the module when it hits or faces like an object. As you can see in the diagram, And the ultrasonic basically has 4 pins, and one of these pins is the trig of the ultrasonic. At 10 microseconds, the trig pin helps generate the ultrasound, and it will send this with the speed of the sound and like an 8-cycle sonic burst, and these cycles are received by the echo pin. And the echo pin is basically, it outputs the sound wave traveled in terms of microseconds of time. And these 3 stages are demonstrated in the diagram here. In terms of connections, they're very basic. And then we just bring a breadboard and an Arduino board and some wires, some jumper wires. Basically, the VCC and the ground. VCC goes to the +5 in the power part of the Arduino board, and the ground goes to the ground GND part in the power part of the Arduino board. And the trig and the echo pins are basically in the digital part of the Arduino board. The trig is the inputs. Also going to discuss the active buzzer module. We use a KY012 module. It has 3 pins, starting with the S, which is the S, and the middle part. The middle pin is known as V, and the final pin is known as ground. So basically, the ground is where we connect the GND and the Arduino board. The V pin is basically left empty. We don't connect it to anything, while the S is connected to digital pin 8. And basically, the buzzer takes in, since it's active, it generates the sound itself. It doesn't need anything it doesn't need an external square wave signal. It's not like a passive buzzer that requires an external, square wave signal, okay? And when it comes to connections, the connections are very simple, as previously mentioned. We just add the S to the digital pin 8, the V is kept empty, and the final pin is basically the ground. It's connected to the ground. That's it.
This product have advantages for both the user and people who are interested on learning about color concepts and features using Arduinos. The coding part and the programming part of this product can be found in the internet, like the sound feature and the color detector feature are available in different sources in the internet, and it is accessible. Also, the materials used in this product are not expensive and can be found in the stores. And this product can be a part of the market and help people who needs it, it will help them to differentiate between the colors, and it will help them to measure and detect the distance between them and the object, so they can grab it and use it without breaking it accidentally by pushing it or something like that.
The project needs some fixation and edit to be applied and used in real life. The first thing is the problem with detecting colors due to difference of light's wavelength from place to place. The second thing is it should be more accurate with recognizing color gradients with the color different level of being dark or light. Also, coding the voice feature in different language like English, Arabic, and many other language would be more useful. Finally, the speaker could work based on Wi-Fi, and that would be more helpful and user-friendly. The main aim of this project is to reduce the communication gap between the blind and normal people. This project is proposed to improve lifestyle of blind people and make it easier. This is also suitable for regarding the communication difference between the blind person and the dumb person. Smart Glove for the blind project is to help blind people determine the color of things, walk, and estimate the distance from obstacle. The main components were used in this project are Arduino Mega, small vibration motor, active buzzer, speaker, and ultrasonic sensor. Ultrasonic sensor is very sensitive and will trigger faster when it detects the obstacle. Other than that, the expense to build up this project was low and can be afforded by blind individual. The limitation of this project was the ultrasonic sensor used can be only detect the obstacle but cannot illustrate the shape of the obstacle. Furthermore, this assistive glove can only be used by blind people, not blind and the deaf people.
The color is green. The color is blue. The color is red.